Howdy, today on Flipping Science I'm introducing organic chemistry. So organic chemistry is the chemistry of carbon and its compounds. Carbon is important because it can make 4 bonds. It's the backbone of many, many molecules. And these are important in organisms, but also in the wider world as well. Down here we have DNA, which is in every single cell. That's organic. Here we have a protein. That's organic. Here we have sugars, carbohydrates. This one here too, glucose over here. They're organic. Down here we have a fatty acid, and that comes from fats and oils. And they're organic too. So many, many compounds in your body are organic, and they're the bits that do most of the work inside your body too. So it's very important that we understand them. So the science understanding we're going to look at, organic compounds can be represented by molecular and structural formulae. Remember the molecular formula of an organic compound given its extended, condensed, or skeletal structural formula. So let's start by talking about the difference between molecular and structural formula. Molecular formula tells me how many atoms of each type there are in a molecule in the correct ratio for what is present in the molecule. There's a thing called a molecular formula that has just the simplest ratio of atoms to each other. Molecular formula tells me how many atoms of each type are in a molecule of that substance. And it's handy for writing down things as shortcuts. So glucose, for example, we'd say C6H12O6, that's how we write it. And that's nice and quick, but it doesn't tell you the structure of glucose. It doesn't tell you that glucose in fact has 2 structures. So none of that information is contained in the molecular formula. So for that reason we have structural formula. So structural formula gives you more information about how the atoms are arranged. And structural formula can be written in a few different ways. Again, the idea is this doesn't represent the 3-dimensional reality of organic compounds, but it gives you a bit more of an idea about how the atoms are joined to each other. So down here we have molecular formula, so here we have butanol. Here we have condensed structural formula, so we're showing the CH3, CH2s. We're not showing every single covalent bond to every single atom, so we call this condensed formula. Then we have the skeletal formula, which is using small lines. The idea with structural formula is that at any vertice there is a carbon and the associated appropriate number of hydrogens to make sure the carbon has 4 bonds. So reading skeletal formula and drawing skeletal formula takes a bit of practice, because you have to remember that every time you change angle that's a carbon, unless you're checking something else in. If we look over here, we can see we've got the electron dot formula. So these are Lewis dot structures showing where the electrons are being shared. We don't really use this when we're drawing structures unless we're learning how to draw structures. Then we have the line bonds. So each line here is a covalent bond. So you're seeing every single bond between every single atom. Then, like I said, we have the condensed, where we're condensing down the hydrogens with the carbons. And then the skeletal here. So what you need to be able to do is, given a structural formula, figure out the molecular formula. And this takes a little bit of practice, so let's have a go now. So let's start over here, nice and simple. So we've got 1, 2, 3, 4, 5 carbons, so we've got C5. Then we've got our hydrogens, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, H12O. Now I would never really write this. The reason for that is you lose the hydroxyl group, which is the important part of this compound. That's what makes this an alcohol. But if we're just doing molecular formula, this is the molecular formula. This is how many carbons, hydrogens and oxygens we have. If we have a look at this one down here, so this is a condensed structural formula. Again, 1, 2, 3, 4, 5, 6, 7 carbons, so C7. How many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so H14. And we have 2 O's, O2. So we've just simply counted out how many carbons, hydrogens and oxygens we have. And this is the order you would normally follow, so CH, then O. If you have any N's, they often go at the end. Right, let's have a look at this one here. Now this one's a bit more tricky because we don't have all the carbons written in. So I'm going to put in the carbons that we need. So again, wherever we get a change of angle, that's a carbon, unless you're told otherwise. And each carbon needs to have 4 bonds, and if it doesn't have 4 bonds represented, that means there's a hydrogen present as well. So if we look at this carbon, there's 1, 2, 3 bonds there, so we need to have another hydrogen over here. This one, so 1, 2, 3, so again we've got another hydrogen. This one here, we've got 1, 2, 3, so another hydrogen over here. This one here, we've got 1, 2, 3, 4, so that one's okay. If we look at this carbon here, we've got CH2OH, that's the 4 bonds for that one, so I don't need to put any hydrogens on that carbon. I think this one is the same, so I think we're okay. So now that we've put those in, now we can figure out how many of each type of atom there are. So 1, 2, 3, 4, 5, 6 carbons, so C6, H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 hydrogens. And oxygens, 1, 2, 3, 4, 5, 6. Hang on, 1, 2, 3, 4, 5, 6, yeah, O6. So C6H12O6. Now looking at that, I can tell that's a carbohydrate, and it's a single unit of a carbohydrate. So that tells me that it's probably going to have a 2-to-1 ratio of hydrogen to oxygen, but we'll look at that a bit later when we go into carbohydrates in a bit more detail. Over here we have another skeletal structure, so let's have a go at this one. So, how many carbons have we got? Now, drawing the carbons that I don't have at the vertice, and then I need to add in the hydrogens to make sure I've got 4 bonds. So this carbon here, 1, 2, so I need to put in the 2 other hydrogens. And this one is the same. My bonds are getting a bit sloppy, but get the idea, I think. And then this one down here. Okay. So let's count out 1, 2, 3, 4, 5, 6, 7. 7 carbons. How many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. C6H17, and then N, we've got 1. Now, here's an important thing to check. If there is a nitrogen, you need to make sure it's got 3 bonds to it. Normally with the nitrogen, that'd have the H's attached to it if it didn't have the 3 bonds. In this case, it's got 3 bonds, so we just put the N at the end. So today for Flippin Science, I introduced organic chemistry. That's it for Flippin Science today. See ya.